let's just have fun. We want to talk about horizontal and vertical control. I think we know it, but let's just talk about it, just in case someone doesn't get it. Is that okay? All right. Horizontal and vertical. Let's start with that concept of when we say horizontal, we're talking about something in the horizon. That's a bit okay. So horizontal, that means that it relates to something within that can be seen within the horizon. So if you stand here right now, anybody who stands up right now in the sky, you can see the horizon quickly. If you can't see it, please, after class, see me. I'll show you. It's the interface between the set where the land seems to have ended and the sky. That's right. Okay. And when we were kids, we saw airplanes fly, and then we say it's falling into some water. It's not really falling, it's gone on the other side. All right. So horizontal things seem to be flat on the flatter end. Okay. As engineers, I believe we know more than this. Talk about looking at maps, for example. Every map tries to represent things on the horizontal plane in planimetry. Okay. So we need to appreciate this. And the vertical, I think Newton did a good job, and he tried to define a vertical line. It's being defined by an apple that is falling. Every apple that falls from a tree goes on a line or follows a certain path. That's a straight line. Are you okay? And so that is the vertical. So you can always create the vertical. I keep saying that physics teachers who taught us and couldn't explain what a vertical is, we're very wicked, because you can actually sit in the class and just drop something. Are you okay? I hope my all right, so out of the question I did that, but anytime you drop it defines a vertical. Are you okay? All right, so simply put, then it means that horizontal has got to do with everything that you do, all measurements within that plane. Are you okay? All right, so I said no calculations, but of course I can make a sketch for us. So it looks more like this. This is the vertical, and that is it. That's it. That's it. Okay, and these axes, they're actually orthogonal to each other. That means they are 90 degrees to each other. And it's defined like that in geometry. Okay, please know. So we're having fun with this topic. So just it's not going to get it. If you guys go for you, means have to be a topic. So vertical, horizontal is we can't talk about vertical plane. All right, you see the vertical seems to be actual points that can be defined within the horizontal plane. Okay. All right. So for any point on here, we can define a certain value. So the point I, x I, y I. Those online, you always don't see anything, isn't it? Try to stay at home.
Your background.
My what? You are suffering.
The background.
Oh, I should change the background, of course. Wow. I set a certain background, so it means how did I do it? So I went to the settings. Hold on. Felix, hold on here.
Okay, sir.
Setting, where's the setting? More controls. Optimize, high stuff. Let's control, annotate, pause. Who knows where the artificial background for Zoom? Anybody who's been using Zoom? Most students don't use Zoom. They only watch it and enjoy it, isn't it? Yeah. Okay, let me go to okay, I think video settings, that's where it is. Background and filters. Okay, so no background. Mirror my video. Okay. None. Okay. All right, so I'm good. Felix, it should be fine. And I don't know if you can even see this.
Yes. Now I can see the board now.
Okay, that's good. All right, so for all the values of x, okay, which belongs to the set of real numbers. Because engineers, we always do it numbers, precise numbers, okay, because sometimes the accuracies are that okay, so 2 millimeter accuracy, all that. So you need to point 2244. All those possibilities constitute a horizontal control. Now, the word control being used there, in fact, shall we say horizontal coordinates? But why are we saying control? Just what it is. It controls the coordinates. Are you agree? Right, so without which we cannot go and actually set our projects. Because our project has to now define a set of points with known coordinates. Okay. All right. So horizontal and vertical control. Horizontal control. But now, how high are these points? That's the vertical. Okay. All right. So I believe we are all happy with this. Can we confidently talk about this? You can, isn't it? Like in your own words, explain. I always ask questions like that. Okay, so horizontal control. The design points of the scheme can be correctly fixed in plan position. So for every, what's about scheme? The scheme is a plan. Are you okay? All right. So how do I go and set it out? I will need to first know that you need to turn this one, go a certain, measure a certain distance, and that is the point. This is where our first column is going to be. This is practically okay. All right. So it's very important to establish points on the site. Okay. And then we establish them and then make sure that we extend the control. So literally, if this are sites, then we need to know these coordinates on the ground, set them out. How do we set the coordinates out? How do we set out the coordinates? It's like saying, find this coordinates. Are you okay? Find the coordinate for the corner of this structure. How do you do that? It's not trivial. So let's make the class interactive. Close and go. Yes. How do you find the coordinates? You're an engineer, right? Your design is being done on an existing scheme, like plan. So you have a scheme on a plan, an existing plan. What do you need to find your coordinates? What do you need? So if I have these, I want to set it out. See, I've explained to you what you understand that the project is sitting on the horizontal. Is all right. I've never seen a building that looks like this before. No. But you are tempted, if you are being real, to think that as you drive along and you see the slope sides, think that, wow, if the building were like this, building it would have been a bit easier. Because now you have to step, isn't it? You have to fail to create. It's as if we always have to create a horizontal level based on which we put up our building. Otherwise, you always have to step. Have you thought about it? Why is that? Say again. A leaning tower. Okay, how describe it to us? I don't know here. In Italy, somewhere. Okay, that sort of leans. Obviously, we have to take into consideration a whole lot of factors, isn't it? Before we some design, every design comes out with its own challenges. It's possible you can do it, but you see, you design a building, all right, and make it look like this, and everybody's clapping for you, isn't it? And then one day someone is walking here, and this falls on your head. They start looking for you. Now you start your theory, ISCP, and you say, please, hold on, let's go into the literature. They slap you. Are you here? What are you talking about? You just kill someone. So in our design, we have to look at considerations. And as much as you want to consider beauty, normally all sort of weird designs are there, but keep it simple and be safe. It's better. Is that not so? Yeah. All right. So back to my question. Let's start with it. How do I implement this? If I know the coordinates for one, so this is like x1, y1. Are you okay? x2, 2.1, y2, y2, and 3. I again that, and so on, up to x and y. I mean, this is how engineers should like we should brainstorm like this, and we send the boys out there to work. Is that okay? Then we know that we are big men. Is that okay? Yeah. How do we put this structure down quickly, guys? Let's do this and then take our money. How do we do that?
By knowing the dimensions.
No. Oh, my friend is here. Hold on. Maxwell, I'm coming. Just let's pause this. Pause. Okay. How do we establish? Get this now, Maxwell. We're going to say something. Open the EU and say, then you put it back. Please, guys, you need to know this.
I think
No, if we're asked to go, just tell me practically. Me, I'm a very practical person. What would you be doing? How do you do it? You see, how to make jollof? You do the jollof, okay? Just do the jollof. You cook it. Okay? How do you make jollof? You cook it.
Sorry.
That's wrong, but how would you need? I will need papa, and I will do this for you today at Amasama. Is that okay?
Yeah.
End of story. Get your money, walk away. Are you okay? Engineer's job done. What do you need to get this established? You have these numbers, which we now want to call horizontal chord. Okay. But what do you need? I know romantic side. I want some romantic conversation. Yeah? You need what? Promise. Okay, you're also not romantic. Even though you're romantic in the real world, the academic world, you're quite not romantic. You're always forgetting me. Jonah, you don't worry me, I worry you. Let me at least remember Jonah. Oh, I can't fail Jonah. Oh, say something, it's not good enough. You see, you won't be doing anything on site. You also to give them the wisdom. So what are these people to get this set up? It's a simple question. So this is what happens. Is that okay?
Sir, so that is set up attention.
Exactly. You need to work from the known to the unknown. This is only in design. On the ground is not there.
Yes.
On the ground is not what? There. So you are the one who's going to bring the projects. Are you okay? We're still more. We're staring at it. It's not, it wasn't there. Someone has to go and say, this is where all this beautiful design by you, the engineer, the structural, we work together. You have the scheme. This is how you're going to do it now. Put the first point here. Sometimes all you need to do is to be set out one point to some projects and tell them this is where this will just grade the place. Are you okay? All right. So horizontal control points have to be what? Identified or brought closer to the site. Where, so that you can actually work from that point, the benchmark to the project. Are you okay? And this is what you do. Basically, what most surveying do is to find the coordinates, then to now say which one am I, what distance should I measure, and what bearing should I take to get to the point. So turn it and then just ask someone to put something there. Are you all right? So you put some kind of marker there, and then now you mark that as a point. Are you okay? But you have to set up on some sort of what? Control. So this on the ground is a benchmark which has it's a permanent feature. And we have the coordinates for it. Are you okay? We can call it TDL temporal benchmark. One, okay, that one. We can establish another one here. TDL 2. Are you okay? And so we have a few of them close enough to our project. without even knowing exactly where it's going. Then we can now try to set the point out. So that's the idea of horizontal control. At this point, we don't even know how deep the project is supposed to be. So before you start doing your, I'm going to cut here and fill there, you need to know where horizontally you're supposed to be. Are you getting that? Right, that's why we dealt with the horizontal control, the strain and all that. Okay, so basically, we need to have these controls. Okay? Yeah.
So there can be a case that there is no benchmark. How do you go about it?
That's what it is.
There's no benchmark.
Yes.
There's no benchmark. Then you have to get it there, isn't it?
Yes.
But I know why he's asking that question. It's good to know, the reason why someone is asking the question. He's asking the question, that's what the question he really wants to ask. Have we met? Okay, anyway. But I know what he's thinking. You know what he's thinking, don't you? When there's no benchmark, literally, you have to find a way to get the coordinates. Otherwise, you cannot work. So there's a cost of doing a traditional survey where you take a backside to a known control and then now turn and locate where the unknown value is supposed to be. Then you can say, break this building because it's sitting where my project is supposed to be. You get that? Traditional. You heard me? That's when there's a control, right? Now, Maxwell's telling me that there is no. So that will bring us to our next, after talking about horizontal vertical control, we are going to be talking about global positioning system. It's a technology. Engineering is also about technology. It's about science and technology. Always remember the definition of engineering. And the day you graduate, someone will come and interview and say, what is engineering? It's a serious story. Is that okay? Always have that. Okay. Metro TV will come here and they will call you. Oh, please, you graduated, eh? Oh, yes. You can't wait to come on TV.
Brace yourself.
Oh my word. Okay, so we solve problem. Engineers solve problem using science. Technology. All right, great. And so you are satisfied. We will talk about how GPS works. Is that okay? In the next few minutes, we'll talk about that. Then that will answer your question because it magically is able to, if this phone contains a GPS receiver, to locate where you are. So that answers your question. Is that not so? Or what were you thinking? Okay. Why should we work from whole to parts? I believe you know this. So let's. Why should we work from whole to parts? When it comes to establishing these controls, why should we work from the whole to the parts? I think you know it. That's what I'm asking. We work from whole to part. It's English language. Are you okay?
Yes.
So we want to start working with the bigger project,
But
and then before we come in and start working with the
departments.
I mean, these are the pictures of the projects. Excuse me, my exam is not for example. Why should we work with the whole before we deal with the parts? So this is engineering surveying. It assumes that you know some basic surveying, all right? Right. Now, for most calculations you do in surveying, you need to adjust for the errors. Now, if you start straight away and you take this code and you bring it here and start working with it, by the time you're done, the whole project should look very funny. In fact, you'll be very embarrassed. You'll be shocked. Something that's supposed to be on this side of the road is going on the other side. And the start is when you're engineering, you're setting something up out. You know that you're supposed to look at the underground. You'll be very sad at me. And you can't push it by force. Or maybe I should just by force put something. Guys, put something here. It will spread it. You haven't been there. You haven't been there. You have to beat. Are you okay? But that is where you're supposed to ask to apply these principles. So you actually adjust these points together. You establish these coordinates together. Adjust for the errors. Okay. and then you try to now get inside the point. So that's why when you ask experience, you don't expect that, oh, just put it there for us. You see him going around. Are you okay? Before he now comes and say, okay, now this is your mouth. Ah, this guy, what's wrong with you? Small one mouth, just 4 points, you can't do it. Okay. All right, if you get a quack, you do it for you, isn't it? All right, so working from whole to part involves starting with a small number of very accurately measured control. I hope it makes sense. Okay. And then you can now move on, and then set out a second level of control points. Sometimes you can come in here and like establish a few control points here. Then you can go in and even start doing the actual, projects. I hope you understand this. All right, okay. So we extend control throughout the site, or we can call it densification of control. Is that fine?
Yes.
All right. Okay, so can we talk about the accuracy? Which one is more accurate? Working both parts? Okay, that's just a question for anybody. Side. Which one is more accurate? Both parts? I don't even have to actually. Yes.
For example, when you are doing settlements on site, and you don't work from both parts. You start from parts to whole. Afterward, you see that your dimensions will be over.
Yes. Having things going wild. I mean, like you'll be wondering, this one is spiritual. You have to be about it. So you are right. You've experienced it. Yes. So that's it. So the national. Why do we need to use a national grid coordinates? Why do we have to do it? Can we use a local grid? Can we use a local grid? I don't know anything that stops us. We could. Yeah, but what's the reason we using national grid controls? So in Ghana, we have the one from the survey mapping division. Okay, we have a national coordinates. Okay. But for now we have the Ghana UTM. Are you okay? Universal transverse Mercator is a coordinate system. Are you okay? Transverse Mercator. So it's it's a whole topic we have to do. Mercator. Okay?
Is that the one that they use something in translation?
Yes, we do that. Ghana, meeting. Are you okay? We have our own. Why? Because when you look at Ghana falls into zones 30 and 31. So for the UTM, the whole world is divided into zones. So this is 31, this is 30, this is 31. Okay, so now which of them are you going to use? You get it? So we have to adjust color, use one. Anybody on the every zone represents one province. With this the universal transverse. It's recommended. It's highly a popular coordinate system. One because the coordinates are in meters. Are you okay? Coordinates are in meters. So it's good for engineering. Are you okay? If you work in meters, you've seen any of our calculations in meters? No. So far. So metric, working in metric is very good. Are you okay? It's not supposed to what? If it's not metric, it's what? Period. Feet, inch, mile. Right? So this coordinate system is one of the most popular coordinate. You can't run away from it. You can easily convert from world geometric system 84, which is actually longitudes and latitudes. Okay. And then get SY coordinates and what we call coordinate transformation. Is that okay? Right. So the world is round, so we can actually keep longitudes and latitudes. And then we can actually bring it to a projected coordinate system. So, okay. So you can give me a set of coordinates which are actually like Ghana 5.41 degrees. No, that's a latitude. So above the equator. The equator is what? 0 degrees. And then we can have maybe 0. 0.1. East. Okay, east of what?
It's of the equator.
East of the. Look at this well. You can't have east of the equator. Think about it. You can't. You can't have east of this. Yeah. You can't have east of it. You get it? It's interesting. Yeah, you can't have it. It's like being on the road going west and someone say that. Go north. It's like I can't go north. See, I say go north. I can't. I get that. Because you already the road is fixed in the same direction. So this is going in east-west direction. So if we say you are east of it, you need a line which is actually a duration. So that's a 0, 1 inch. Is okay. And this is a 0. So these are the references, are like the origin of this geographical coordinate system. Is okay. And this coordinate system, the north pole is here, south pole is here. And then you can now exactly this coordinate system we call UTM is based on this. In other words, you can just convert this into that, what we call it map projection, which we're not talking about in this class. We want to appreciate the fact that we can actually transform coordinates from one coordinate system to another. Even this weird coordinate system, which is actually spherical, can be converted to a grid form in what we call the projected coordinate system. Projected coordinate reference. So this one is not projected. Okay. Because talk about projection maybe in another course. But you can see that definitely this is what engineers are used to know this. And in of these calculations we did, if you are to bring this in, then we will leave the engineering for you. We say we want to be engineers, but thank you very much. I don't want to. So this is how we want our coordinate system in a grid-like fashion. Have a grid, which is actually the lines are actually what that's polarly spaced, and then we have equal space between them. Yeah, intersecting at what 90 degrees, right? That's the kind of coordinate that I'm referring to. So the GPS will probably give you something like that, Maxwell. And then once you get that, you can now start, transferring the coordinate. You in the end, you need a total station. Okay. If you want to show exactly, even though people have used GPS, you have to be careful with your use of GPS. Okay, the accuracy. For example, if you take your phone and decide to bring set as you'll be in trouble. Time you're done, you're looking for a square, you have a what? Trapezoid. Use to come for it. Yes. No, because now Lands Commission is coming with laws about mapping. Are you okay? So if you're not careful, there are mapping policies. That will check that if you are qualified to do it. Okay. All right. So I think we really touch on this. Horizontal control points should be located as near as possible to the sites. Site, why is that important? Why should the horizontal control points be located as close to the site as possible? Why? Okay, quick answer. Anybody?
Reference point.
That's a reference, but the distance for to reduce for easy access. Okay, easy access is one of them. The other one is it's going to cost you a lot. Yes.
Yeah, I was saying accuracy.
For good accuracy, exactly, because you see, the more you try to extend your control and you introduce human errors into it, are you okay? So I have to take a control from all the way from the main road to this place. By the time I get here, I'm a bit off. You see, tells you that the errors are compounded, they are cumulative in nature. Okay, So as you come, it adds on a little bit of error. You turn, the surveyor gets a bit angry. You know. Are you with me? All right. So accuracy is very important, okay? Horizontal controls, they have to be fixed. When you talk about TBMs, benchmarks, you have to fix them. Are you okay? It has to be permanently fixed. So if it shakes or it moves, that's not going to help us, is it? You have to re-establish it. So it's very, very important to do that. All right. So in some sites, I remember at Heathrow T5, there was a grid for the site. So every work you're doing, you can refer to a particular grid. I don't know if anybody can relate. A grid for the site. To establish that so that there's a north direction in every element, okay, of the construction can be referred to this. In that case, you have some sort of local coordinate system. Is that not? All right. Okay, what about vertical control? I think enough of this one. Of course, primary, secondary, you get secondary from primary. So primary control, secondary control. Are you okay? Right. Same things, same concepts apply to vertical control. How do you establish vertical control? How do you establish vertical control? What is a vertical control? Yeah. Yeah. This one doesn't need definitions. How do, in your own words, what is vertical control? You know it already. So prerequisites need to have 100% knowledge in some thing before you're allowed to do something. Vertical control. Yes, what is vertical? You don't have an idea. Anybody has an idea? So we said, what is horizontal control? It's defined by a pair of numbers that indicate how far we have from the origin in a Cartesian coordinate, some sort of coordinate system. Are you okay? Right. So y, x. Okay. So where is the z? It's coming out of the board. Are you okay? Right. So I'm going to build a square. Build it here. Okay. It comes up. I'm going to go here. Students. There you go. Are you okay? So without the high information, there's nothing. Everything is looking like cartoons, even Captain Planet. Without vertical information, right, or data on the vertical, you have nothing. Everything is what? Like flat. Like a car running over what? A cat. Why a cat? You don't like cats. Choose a different. Like a car running over. No one car, they can swallow road. Cars always run over dogs. That's a flattened one. Of course, let's take a mind from that is a big goal, isn't it? Let's look at cartoons. You know, it's a cartoon called Road Runner. To teach the children not to cross the road anyhow, so that they don't die. Are you okay? So he did a cartoon in such a way that there's a guy in the cartoon, the cartoon character, not a guy. And then what this cartoon will do is that it just going to stand on the road, you know, crossing, and wants to cross, and it just be there. It's so meticulous at checking, very careful at crossing the road. Why have I told you this story already? It's good at it. I've been telling the same story. Okay, so basically, you look left, you look right, you look left, you look right. Then you just step in the road like how long? You get it? So it means it's even saying that it doesn't matter how careful you are, it still knocks you anyway. You get it? So that's what we do when we have just the horizontal down vertical. So you see, let me tell you, the reason why you probably need to reference how the height on your side. Reference to a datum. So now the vertical has see the word datum. Start thinking vertical to help you. Example, a reference date is the MSL. What's that? Who's my friend here? That's all. Go ahead. As for Jonah, he's not my friend. I'm telling the class. Sad, you know, from your relative, I'm standing here. Oh, uncle, happens. You are supporting the class, isn't it? Okay, so going to reference it to MSL. What's MSL? You can tell me. Whoever tells me if you call me, tell me. And someone's going to get it now because I've made it.
And there is no come.
What's MSL? Huh? What's MSL? You get it and you fail, call me. You say, I'm the one who said MSL. And then I'll change my mind. It's okay. I'm like, okay, since you didn't get it, so that offer is gone. Anybody who says it later on is gone. I give you just 2 minutes. Is that okay? Mean C level. Mean C level. But you know we can see the C, right?
Yes.
So if you don't get the concepts, she puts you on the table and lash. You know, like because that what's the idea? The idea was so that there will be no arguments. So that's why we can establish the tallest mountain, the tallest building, because there's a common reference. And also there are low-lying places that we need to appreciate. Are you okay? All right. So that all our research and everything we do scientifically, we can have a common reference. So for the whole world, when you go to any conference and mention this, doesn't matter the language they're speaking, they will understand. Except that maybe in some country, in some country called no, in some country called at 31st, you are not in this country. Emofia. Country called Emofia Day. We didn't contribute to this. That's the point I'm making. All right, you understand that? Well, we didn't care, did we? But lack of knowledge, it doesn't help. Are you okay? So we need to appreciate what is going on. When I went to Kumasi, I visited, I told you already, they said there's a water body. In Kumasi, you don't have like sea, there's no sea. So we appreciate lakes and rivers. Are you okay? And so someone said, I'm taking you out. I'm like, wow, you are. The lady who bought a shoe for me. He said, I'm taking you out. I said, okay, fine. Because I was like, oh, this girl, why just give me pressure? So I just, okay, I'll go. All right. So basically, we just go 2 kilometers away from where we are at the outskirts around the Achuma area. And then we find this huge lake. You see this?
Yeah.
You see it? This is the review.
Okay.
Hey. So that's what people don't know. There's another one around the Kadash, back of Kadash. Yes. And there's a, you can go on a boat. I mean, it's the new thing. It's not even Barry. So now you have even. When did you go to? It's not Barry. It's not even. Some small. Okay, well, of course, anytime you create a dam, there's a river, isn't it? That has been blocked. It's just beautiful.
But we don't appreciate it.
Do we? Look at it.
Very big.
That's money.
I did my service around.
Okay.
So I know where it's actually.
You see that?
Very big.
Yes. It's bigger than we think, isn't it?
Yes, bigger than it's very, very
big. And long. In fact, I think I know the sheep. Yeah.
Very big. Because I've walked around the banks.
It just comes, hits the road, this road. As if you're standing, hits it like that. And
castles in some own road.
Yeah.
It's very big.
Yeah. Very big. We need to update the level, height. That is why control is important. So let's have controls that we have the X, Y, and Z. So you can have a lot of it anywhere you want to have it. in the set of real numbers. Are you okay? All right. Great. The day2 then becomes the line from which you are measuring from. So you can have a mountain. So here I'm measuring below above. Are you okay? So the point is your height. But this, if it's MSL, is a day2 as accepted, we could literally say that ZA is equal to the eigenvalue. And then add it to this numbers and have a triplet of numbers. That become the coordinate. Are you okay? All right. So vertical control points of known elevation related to some specified day2 must be established on the site. It needs to be established there so that the architect can work. If you understand architecture, are you okay? Realize that what do? They advise on the projects. They are part of they are usually the team leaders, the engineering team. And they tell you that you can't do this. Projects can't do it. Can you imagine? Or the orientation. Are you okay? Someone is saying something. Oh, your mic is just on. Do you want to say something?
See Felix? When you are writing on the board.
You can't see what I'm writing. Okay.
The bottom part of the board.
Can you see it now?
No.
Can you see it now?
It's I think no, please. The bottom part of the board.
Once you see the bottom part, me too, I can't see the top part of my laptop. Okay, so you watch what you can see, okay? Because I have to also assess my PowerPoint. Okay.
Okay.
So you can't just have a control, okay, with a height value without any XY coordinates. Okay?
Yeah.
Is that true? Let's say you know the Z, but you don't know this one. It is just not possible. Why? Why is it not possible to have just a Z without XY?
It gives you
where it is. Yes, it's place where this is where you are, and this is your value. Are you okay? But you can just have the XY without the Z. So in that case, you just don't know how high it is, but at least you know where it is. So it seems we start with the XY.
So when you are doing it, when you apply for the points,
yes,
you have the X and
you usually have all that.
And when you start the project itself, implementing it,
yeah, exactly. And so literally you mark the points on the plan. The heights are now imposed on it. Are you okay? As if it's an attribute of the locations. Okay, so what's the process of determining the heights? What's the process of determining the heights? What is it called? The process of determining heights and elevation. It's just one word. If you don't know, you know. Or you feel that place? I don't think so. You don't look like you feel it. Just that because of the way I'm talking. In 10 minutes, fellas, please try and join me again, okay? What you see on the board is what we are talking about. So I think for you, you are even ahead of them. You can see everything. How do you determine the height? What's the process called? Jonah? Point two. That is 2 pieces. Yeah. What's it called? You heard it before, haven't you?
Leveling, yes.
What do you do to do it? What instrument do you need to do the automatic, level is price of what it is, but you can use total section. You know exactly what you want. Okay? And now we even have Trimble has an instrument. You can just put the coordinates and press it. Then to point and say, this is where that point is supposed to be. Now you take your reflector there, okay, and then it tells you that okay, you are too high. Then the instrument will calculate. It tells you that bring it down. Okay, so let's see if you are setting out something. You can just say they should break just to make way. Okay. But if you don't have the basic understanding, you do know that, but one day you'll be in a mess. You can just be fired. That's why we have to learn some of the basics. Are you okay? All right. So if you have a total station set up here, I know you've done this before. Let me just teach you. And you have 11 instruments here. And you take a reading of R. Okay.
So I'm coming. Is it total station 11 instruments?
So you have 11 instruments here. You have the staff.
That's the start.
We have the. Sorry, I said something.
You said total station.
Sorry, we have 11. Okay. And then you reach the value you get out. Okay. You made a reference to a point here with reduced level of 50. Is this good enough? The question, this is the question, is it good enough to determine the height at point Q? This is a lecture, remember? So I'm talking to you. I'm talking. That is why it's called a lecture. It's like I'm a pastor. Every lecturer is doing just that. A teacher does something else. What?
Yes.
How? How would I do it?
So the staff, there are numbers on the staff. So you use the.
No, you've read it. You got so you read. So you definitely stand here, isn't it?
Yes.
So that's the master. Listen.
Yeah.
Right. It looks through this. Looks here. You said you can't.
Yeah.
You can't. Why can't you? Come on. You can't.
So you can't.
So you are not mathematical. That's why you didn't get it.
The level machine.
Can you, with the information provided, can you?
Tell me, I think you can't.
You can't, right?
4 points.
You can't, right?
Yes.
You can't. So you can't. That's because you're not writing the formula. Are you okay? Let's try to write the formula. Are you okay? What should be the formula? Add this region to this. And call this one. Gives you this one.
Yes.
And you subtract R.
Yes.
Then to bring it to you. Okay, this is not in the notes. I'm lecturing. And try to make sense with me. You got what I'm saying? Because this value here shows you that 56 is 50 above base level.
Yes.
That is definitely going to be below
Base
base level. So that's where the argument starts. So as you think, and this is getting higher. Now, since it's deep in there, the reading is going to be very high.
Yes.
And then I'm going to take it out. People will still bring it, but it's some kind of, there are two, like, there are ways, methods for doing the reduction. Are you okay? Yeah. To find a reduced level.
So
reduced level.
we use the rise and fall method.
Very good.
And
So rise and fall method.
height of combination.
And then how you combine that. Height of combination.
Yes.
Okay. Right. So you can just play around. Are you okay? So if you're on a site, you can just use this and look relevant on the site. Are you okay? or talk to people, and they will think, okay, he knows what he's doing. I say, okay, what's the hierarchy? Come on, let's do this. Let's go. It's okay. Just this basic idea. All right. Okay, so basically that is the way it is. Should we work from whole to parts for leveling? Should we? We should, shouldn't we? We should, yes. The same applies. All right. How would you fix a TBM that has a vertical value? How would you fix it? Size. If you have a temporary benchmark, okay, the benchmark has a control, right? It's a permanent feature that has coordinates. How would you establish it? What would be the consideration? Now I'm talking about physically. How do you put it down and say this is a vertical control? How would you do it? Oh, because it's vertical, you get it. And obviously, it will be good to just get it, permanently fixed in such a way that you won't have a change in the height. You get what I'm saying? So, if you're going to be planting, say, a pillar in a soil which is not that stable, it's going to sink by 0.1 or 2, which is the reason why you got fired. Okay. Do you get what I'm saying? So that 0.1 now, it's enough for something not to fit in the structure, in your structure, whatever you're setting. So it's very important that you fix them very well. And I've seen vertical controls established way back before independence or something. They are still there. And they fix them intelligently, wisely in schools. Children have been playing it, never knew that little thing there contains a value. Are you okay? So there's an argument between the kind of coordinates you are getting from GPS, okay? The ellipsoidal, maybe we'll talk about that later. And then also the one that you get from the level. There are 2 different heights. Okay. The one you use the damping level to get is what we call the orthometric height. Orthometric height. Okay. Okay, you also make sure that you level the instrument. You get it? So that's why we call it orthometric. Ortho means what? 90. Orthogonal. Or anytime you hear that, even in AutoCAD, ortho means exactly. And they are under the influence of gravity. So later on, that should also be there. But that's beyond that scope. It's okay. All right. So let's look at how this is. Obviously, you can make use of bolts, anything that works. I saw it's like a metal that's been driven into. Have you seen these primary schools?